Hi, my name is Susanna Gordon, and this is my Lab 2 video for Professor Junker's Physics 2212 class about electricity and magnetism. So let's get into it. So basically, the purpose of this lab is the same purpose of our lab last week, I guess, for lab 1, where we had the exact same procedure of you would put tape on a table, put another tape on top of it, rip it off, and figure out the charge of it. You did that for 2 different tapes and held them above it to get one to kind of float or hover above it. And then you measure the distance between that, and the whole idea is to try to figure out what the charge is of one tape. So it is the exact same procedure as last week, and as you can see, this is the model where the upper tape is the one that would have the charge and the lower tape does not. So this is kind of the whole idea behind it. And like the lower tape, as you can see, kind of takes the electrons off of it, or it keeps the electrons off. So the physics principles that are part of this are like Newton's laws of motion. So to kind of calculate, we calculated what the gravitational force should be, which is, mass times the acceleration due to gravity. We also had electric field and electric force in this because in the program we used our function for electric field from lab 0 to calculate the electric field of each of the different points. And you have electric force, and electric force has to be equal and in the opposite direction of gravity, which is Newton's third law because it has to not third law. It's the second law because if there is an equilibrium, then it will be okay. And then we also had the superposition, which is basically adding up the different vectors. And we're going to get into this into the next slide. So lab 1, we were just looking at it as a point charge, but in point 2, we're looking at it as a line of charge. So we have n, which is equal to how many charges are in the line, and you calculate the electric field or on each line, at each point on the line, basically. And then you use superposition and the vector addition in the program to add them all up, and then you're able to figure out the charge. So in my first experiment, I got my electric force and gravity to be 0.00196 newtons, and so I calculated the charge of the tape to be 9.33 e to the negative 8 coulombs. And this is just saying we very much simplified it down to 1 point charge. But in lab 2, we got it to be a very similar value of magnitude in the electric force, but we got the charge of the tape to be 7.1395 e to the negative 9 coulombs. And that is from the program. And this is really important because then it comes into play with our model because instead of looking at it as 1 point charge, it's multiple point charges. This is my code. It's very messy. The main takeaway is that I was able to add in the numbers that were needed, and I had the amount of charges on the line to be 10 because my program was having a hard time running if it was anything greater than that. But if it had more charges in a line, then it should become more and more accurate is the entire thing because that's more representative of what's happening on the line of tape. It's not just 1 point charge, it's multiple. So basically this is my program, and so the top tape is a bunch of red little dots, and the bottom tape is a bunch of blue little dots. And so anyway, I'm going to get to the model to basically explain what all of it is. So the red balls up there are the upper tape, and then the blue dots below it are the lower tape. And that yellow line going down is the gravitational force acting on the top line, and the white is the total electric force acting on it. And all those green little lines are the electric force at each of those points from the lower tape, which is a very accurate model, and then when you use superposition to add them all up, it should be equal and opposite of that of the gravity vector. And so using this and a lot of kind of guess and check, I was able to get my final charge to be the value I mentioned before, which is 7.1395 e to the negative 9 coulombs, which is different than what we got from lab 1, where we just simplified it so much that it was just a point charge. So final questions. If we model the charge like the single point charge in our lab, it's going to be a different value because you've simplified it so much. So basically, the difference between them, they are a little bit different and stuff. They're such small numbers, it shouldn't differ too much, but they are different. And the thing is that it's because in the first experiment, we simplified it so much from the original case to make it easier for us to calculate on our own, that is why you get a different value, while this model is more accurate. And which value is closer to the real value is the one from this model, and the more charges you add in a line, so if you make n 100, it should be a lot closer to the true value of the charge on the tape, basically, because that's more representative of what's happening on the tape. There's not just one charge particle on the tape. There's going to be a whole line of them. So using this kind of helps you figure out, oh, this is more accurate to it, and it is harder, which is why we have the whole program to figure it out. But I really liked this lab. I thought it was a lot of fun. It was a good continuation of our previous lab, and it was a really good way to use what we know and kind of build off of what we know from like Newton's second law, and that's equal and opposite for them, so that the tape is in equilibrium. But we were also using the idea of superposition, which is something that is really important in this course. Well, I'm sorry I went a bit over, but I hope you liked this, and I hope you learned something new, and thank you for listening.